How many bags of flour should he buy?
Okay, so what are the two numbers that you see in the problem here? What are the two numbers?
3 and 15.
3 and 15. Okay. So there's a couple of ways to do this. One is you could think to yourself, what are the possible ways that I could combine, these numbers?
Add.
You can add, you can subtract, you can multiply, and you can divide. Okay. But we know that one bag here is 3 pounds.
Mm-hmm.
Okay. And we're trying to go to 15 pounds. What's a way that you can go from 3 to 15?
You could times 3, 6, 9,
Exactly.
12,
Because
15.
because because what you're doing here is the numbers are getting larger. There's two ways to get larger. You can add or multiply. Okay. So you're correct. Now, what number do you multiply 3 by? What number do you multiply 3 by to get to 15?
5.
5. Okay. So we know that we're multiplying 3 times 5, which means that you have to do the same thing over here. You have to multiply this number by 5. How many bags would that be?
15.
Well, 3 times 5 is 15 pounds, but we're interested in the number of bags. What is 1 times 5?
5.
5 bags. Good. Okay. So there's only 4 math operations that we need to worry about. And we just talked about this idea that if you're going larger, you're either going to add or multiply. If you're going smaller, what are the 2 math operations for going smaller?
Um, uh, Subtracting,
Yes. And?
dividing.
Yes. Very good. Okay, so let's look at the second question here. Okay, Jack wants to make some cookies for his mother. Do you like baking, Finn?
Yes.
All right. What do you like to bake?
Cookies.
Cookies. Cookies are good. Okay. The recipe says he would need 7 ounces of flour for 1 batch of cookies. 7 ounces of flour for 1 batch of cookies. So we can say that 1 batch equals 7 ounces. OZ is ounces. He wants to make 4 batches of cookies. So see how I'm circling the numbers in the problem?
Yes.
You want to do that as well. You want to circle the numbers as you read it. That would be a really important thing to do, or highlight them if you prefer. So do we know how many batches or how many ounces we want?
Batches.
We want to make 4 batches. So how do you go from 1 to 4?
You count.
You can count, but we have options. Are we getting bigger or smaller going from 1 to 4?
Bigger.
So we're either adding or
Subtracting.
multiplying. No, we're getting bigger. Bigger, larger, or bigger. You can only do that by adding or multiplying. So how can you go from 1 to 4?
You can plus.
Okay. Now, that's true. You can add 3, okay? But let's do it differently. Let's talk about this in a little different context. 2 batches would take 14 ounces because you're doubling. You're
Yeah.
doubling to go here. So whenever you're doubling, that's multiplication by 2. Three
Oh,
3 batches would be
21.
21, and then you could keep counting here if you wanted. 4
28.
batches. Yeah, 4 batches is 28 ounces. But how could you go there directly? Like, what if this wasn't here?
You
How
could times
times it by what? What
4.
number? 4. Does that work over here? It's times 4 also?
Yes.
Okay, great. Excellent. Okay, any questions on that?
No.
Okay. Let's look at another problem here. All right, could you read this one out loud for us, please?
Emily bought 1 pound of 4 ounces of ground beef for her mother for dinner. But her mother says she only needs 8 ounces of ground beef. How much extra beef did Emily buy?
Good. So Emily bought 1 pound and 4 ounces. It's not really written well, but it's 1 pound and 4 ounces. Okay. Do you remember from class how many ounces are in a pound?
16.
Yeah, so it's really like 16 ounces plus 4 ounces. How many ounces is that total?
20.
20 ounces. Good. Okay. So she bought 20 ounces. How much does she need?
8 ounces.
8 ounces. So are we getting bigger or smaller?
Smaller.
So what are the two math operations for smaller?
Um, Dividing and subtracting.
Subtracting here. So subtraction is the right operation here. What's the difference between them?
One's bigger and one's smaller.
Okay. What is the difference though between these numbers? What is 20 minus 8?
Um, 12.
12 ounces. Very good. Okay, very good. Any questions on that before we move on to the next question?
No.
Okay. Let's take a look here. So this one's very much related to the previous one. All right. So let me grab this in here. Okay. All right. Okay, so it says the turkey is 19 pounds and 12 ounces. 19 pounds and 12 ounces. And the stuffing inside the turkey is 4 ounces. Okay, what is the total weight of the turkey? So the picture is you have and I'm not very good, so we're just gonna call this the turkey.
Okay.
Okay, and then the stuffing. All right, so this is in ounces though, and the turkey is in pounds and ounces. You can only combine ounces and ounces,
Mm-hmm.
and you're adding them together. So when your teacher says to draw a picture, you're not going to actually draw a picture of a turkey, although that would be really good if you could.
Yeah.
You're trying to show the representation of the problem, with blocks or in this case, you can show them adding together, things like that. So what is 12 plus 4?
16.
16. So that's 16 ounces. How does that convert to pounds? How many ounces are in a pound?
16.
16. So this is really 1 pound. Do you agree with that?
Yeah.
So this 19 pounds combines with the 1 pound to make how many pounds?
20.
20. Very good. Okay. Seems like you're getting this down pretty well here, especially when I talk you through it. Let me take a look at what else Mom sent over, to see what else we can work on today that might be a struggle here. So let me take a look here. All right, I'm just looking at some of your other work. My circle changes. Okay. Okay. So let's talk about some rounding. Looks like rounding might be something that you've struggled with. Is that possible?
Yes.
Okay. And rounding is very important. So we'll just spend a little time talking about rounding and then we'll maybe get to another topic. So let's say I give you a number like this, 5,387. Do you remember the name of this digit right here, this first digit? Do you remember what that is
7.
called? Yes, but it is in what's called the ones place. Have you heard of that before, the ones place?
Yes.
Okay, I'm gonna just change this. What place is the 8 in?
The tens place.
The tens place, okay. And how about the 3? What position is that in?
Hundreds place.
Hundreds. And how about the 5?
Thousands.
Thousands place, okay. Very good. Okay, so now let me rewrite the number here. 5,387. And let's say we wanted to round to the nearest 10. The nearest 10. Do you remember the rules for
90.
this? So give me the full number. Just read the digits. Tell me the digits.
5387.
No, the rounded number. The rounded number. Because you told me the right number, but I want you to give it to
90.
me.
He
Give me
wants
the
to
full
say the
digits.
whole thing
5.
from left to right.
Yeah. Yes.
5390.
Very good. Very good. Okay. Now let's do another one here. I want you to round to the hundreds place on this one.
6300.
Very good. You definitely have this down. Okay, that's good. Let's go 77,000. All right, I want you to round to the nearest thousands place.
7000.
Just read the digits. Yeah, just read the
Yeah, you
digits.
could
Don't worry
just
about the
say
number.
7 and 7. You don't have to say 1,000, honey.
7700.
Okay, but there has to be the same number of digits as before. So you only gave me 2 zeros. There needs to be 5 numbers, 5 digits total here. But I think I'm getting the sense you do understand that. All right, let's go back to some word problems here. I know that word problems are very frustrating. They're difficult. That's okay. We're going to get through it. We're going to knock these out and hopefully give you a little bit of better understanding of how to do these. Okay. Arthur buys dinner for his friends. The bill comes to $16.23. Gives the waiter a $20 bill. How much will his waiter bring back in change? So I want you to tell me, what are the two numbers in this problem that you see? What are the two numbers?
$16.22 and $20 bill.
Okay. Now there's a lot of things that we could do here. We could add them, we could multiply, we could subtract. What do you think is the right answer here?
To subtract.
Why subtract?
To see how much.
So whenever you're asking for how much is left over, that's a subtraction operation. And that's essentially what we're asking here. Now, do you remember what you put in this position on the right of the decimal when there is nothing there? Do you remember what goes in those positions?
0, 0.
0, 0. Very good. Okay. All right. Do you want to try subtracting this on your own, or do you want me to help guide you through it?
Help.
You want some help. Okay. Is 0 smaller than 3?
Yes.
Yes, it is. So we have to borrow. Can you borrow from 0?
You
There's nothing to borrow from.
turn that into a 9.
Well, you will eventually. Can you borrow from this zero?
Mm-hmm.
No, you cannot borrow. You cannot borrow from zero. You cannot borrow from zero. You can borrow from any number besides zero. So this two becomes a one, and you're right. These become nine, and then what does the last one become?
10.
10. Okay. What is 10 minus 3?
7.
What is 9 minus 2?
7.
What is 9 minus 6?
3.
What is 1 minus 1?
0.
You write 0.
No.
Why don't you write it?
Mm, because there's there's nothing in zeros, so it
Okay,
can't
that's
be
good
a
enough for
number.
me. So this is the change. All right. So let's change the problem up a little bit so you can try one on your own here. This is one of the reasons I asked you to get chips and paper. Let's say this time the bill comes to 30. Let me write the number down here. Let's say the bill comes to $38.12, and you give the waiter a $50 bill. A $50 bill. Will you try this one on your own, please?
Yes.
Okay. And if you're not sure what to write, please say so. Please say, I'm not sure, or help me out here. But go ahead and give that a try, please.
$28.12.
Okay, so did you put 50 in the top?
No.
But it's a $50 bill. So 50 goes in the top, and then $38.12 here. So this is like the previous one. Do you have the previous one down in your notes?
No.
Okay, you got to write it down. That's why I asked you to put something down on paper. Do you, so let's work through this together. Is 0 smaller than 2?
Yes.
Okay, so you can't do that. Now, can you borrow from this 0?
No.
Can you borrow from this 0?
No.
Can you borrow from 5?
Yes.
Okay, what does 5 become when you borrow from it?
15.
It reduces by 1.
4.
4. So this becomes a 4. What happens to this first 0?
It becomes a 9.
Okay, what happens to the next 0?
A 9.
Okay, and what about the last 0 on the right?
A 10.
Okay, so I want you to subtract these numbers on your own, please.
Okay. $11.88.
Okay, very good. All right, so this time I'm just going to put the numbers in front of you, the problem in front of you. I want you to try this on your own, though. Let's go 30 minus 16.54. So I want you to try this one on your own. It's just like the last one we did, just different numbers.
$13.45.
Not quite, pretty close, pretty close. So did you change this to a 2?
Yes.
Did you change this to a 9?
Yes.
Did you change this one to a 9?
Yes.
What does the last one become?
A 10.
What
Oh.
is 10 minus 4? There's the difference. 10 minus 4?
6.
6. All right, let me set up this last one for you.
Okay.
So there's another word problem here. It says DW is at a baseball game and he buys a bag of popcorn that costs 98 cents. He gives the catcher a $5 bill, so it's a $5 bill. Take away 0.98. So this is just like the previous problems. What do you do? What's the problem here? 0 is less than 8, so you have to borrow. What does the 5 become when you borrow?
4.
4. What does this 0 become?
A 9.
And what does the last 0 become?
A 10.
All right, so could you subtract for me, please?
5, 4, 3. 0, 4. $4.03.
How did you come up with 3?
10
What is
minus 8.
10 minus 8 is 2. And
Okay.
9 minus 9 is 0. 4 minus 0 is 4. All right, good job. We're going to go ahead and stop there for today.